Hello everyone, I am Om Prakash Maurya from IT Guwahati. So today I am going to take the week 6 hydraulic engineering PMRF live TA session. So actually I was unable to take live TA session on 28 Feb 2025 due to the network issue. So I am going to record the video of week 6. So the topic is, let me put it in the full view mode. Okay, the topic was introduction to open channel flow and uniform flow. So open channel flow, as you all know, the open channel flow is defined as the gravity flow, the flow due to gravity, and uniform flow, you all know the depth. Okay, I'll discuss later in the coming slide. So here just before moving on the some definitions, let me just discuss a little bit a numerical point of view, the open channel, what is your open channel and what are the fundamentals of open channel, fundamentals component of the open channel. That is the calculate the weighted perimeter of rectangular channel having top width 4.5 meter and depth 3 meter. Okay. Okay, let me. So here is the question is given. One rectangular channel is given. This is the rectangular channel. The top width is 4.5 meter. You can say the rectangular channel means top width or bottom width will be the same because here the channel is rectangular. So 4.5 similar your 4.5 below meter. Depth of 3 meter. Here depth is 3 meter. Right. So calculate weighted perimeter. So here I want to just tell you what is area of rectangular, you know already. Area is, that is your depth into width, right? And what is perimeter? Perimeter is nothing but the sum of, here I want to write the sum of length, that is unit will be meter because we are talking about here the length. What length? The perimeter means the sum of weighted length here, because in the question asking the weighted perimeter, weighted length. So if the water up to here, so weighted length is this much, and this much. We are not include this one because here is nothing. This is this one is A's, here is one A's, two A's and three side. The fourth side is open, so here is not your, the fourth one is not weighted, so that's why we will not consider because here is no wall, only three walls, so we'll consider these things only. So perimeter will be this one, that is your 3 plus 4.5 plus 3, how much? 336, that is 10.5 meter. The perimeter will be 10.5 meter. This is very basic and fundamental. And here another term also, the hydraulic radius. Hydraulic radius. What is hydraulic radius? Weighted area by weighted perimeter. This is your weighted perimeter, right? So here is what is your weighted area? Weighted area means depth into width. 4.5, 3 into 4.5 plus 4.5, that is, here is 2 into 3 plus 4.5 means 2 into 3 plus 4.5 means what? That is divided by 10.5. This is the value of your hydraulic radius. And what is hydraulic diameter? Here is also one important thing. Hydraulic diameter. Diameter. Hydraulic diameter is nothing but 4A W by AP. Remember, not AP, PW. That is weighted perimeter. So hydraulic diameter is 4AW by PW. Means hydraulic diameter is related to your hydraulic radius. If I write here HR, that is 4 into HR. Generally your diameter related with 2 times of R. But in case of hydraulic, the hydraulic diameter is related with 4 times of hydraulic radius. Always remember, these things will use in this your hydraulic diameter concept will use in the calculating the Reynolds number in case of open channel flow. As you all know, in case of pipe flow, we write the Reynolds number for, okay, we'll discuss coming slide we'll discuss. Okay, so here is next question is the Froude number. The Froude number of a flow of channel section is 1. What type of flow is? What is Froude number actually? I have already discussed the ratio of viscous force, that is the gravity force, divided by viscous force. Gravity force divided by viscous force. This is the definition. So after putting the value, you will get the gravity force value and the viscous force value. You will get the final V divided by G into area by top width. FR you will get. Area by top width, sometimes we write as a D. Remember please, in case of rectangular channel, the area is B into W and top width is your B, or D you can say. This is D. If this is D, the depth of the flow is D and width W. So area is equal to W into D and top width is equal to W. So here if you will put, only D will be remain. So in case of rectangular channel, your Froude number is GD, small d, that is the depth of the flow in case of rectangular. But for another channel, you apply this one, V divided by root GA by T. Remember please the Froude number. If your Froude number is equal to 1 for a flow, that type of flow known as critical flow. We'll discuss later. Okay. Reynolds number, what is? Rho. Here actually in Reynolds number we talk about the characteristics length. We talk about this characteristics length. In case of pipe flow, these characteristics, in case of pipe flow, we take as a D, and in case of open channel flow, we take this one, HR, hydraulic radius. In case of pipe flow, that is pressurized flow, we take this L is equal to D, but in case of open channel flow, we take at place of L is HR. One thing in generalized way, we can write the Reynolds number is rho V, that is average velocity, into hydraulic diameter divided by mu. So this formula we can use for both case. HD means what? HD means 4 weighted area divided by weighted perimeter. In case of pipe flow, that is pressurized flow, weighted area means how much? Full weighted area. Pi r square. And what is perimeter? Perimeter means pi r. That is this one. Here you can write. Or pi by 4 into d square. In terms of diameter, I want to write because here the d will come. And perimeter is pi d. So area by perimeter, what? If I put HD is equal to, if I write here, HD is equal to 4AW by AP, that is PW. 4AW means pi by 4 into d square divided by pi d. So pi will be cancelled out, 4 will be cancelled out, d will, only d will be remain. So HD is equal to d in case of pipe flow. If your pipe is flowing full, so means HD is equal to, you can write here d, RE is equal to rho V d divided by mu. So in case of your pressurized flow, you can use this formula, but remember at the place of HD you need to write, you need to apply this formula. In case of open channel flow, let me just discuss about this. For case of open channel flow, so 4 into AW is what? AW is okay, AW and AW by PW is what? We have defined already the hydraulic radius HR. So we can write here RE is equal to rho V 4 HR divided by mu. HR divided by mu. This is means what? One thing also I want to tell you. In case of pressurized flow, the Reynolds number is 2000 for laminar case. For laminar case 2000. In case of pipe flow, this Reynolds number is 2000. But in case of laminar flow, what should be the value of your Reynolds number? In case of open channel flow, in case of laminar, what should be the value of this? So from here you can easily calculate. In pressurized flow, here you need to put 2000 is equal to how, what is equal to this? Rho V into 4 into HW divided by HW, sorry, let me just take eraser. Okay, so here rho V into 4, not 4, HW divided by mu. Okay, so the value of this is equal to 2000. But in case of open channel, the Reynolds number is defined as like that. The Reynolds number is rho V HR hydraulic radius divided by mu. At the place of HW, we can write 4HR. So if you will put here 4HR, what will happen? Rho V HR into 4 divided by mu. So this value is Reynolds number in case of open channel flow. This value, rho V HR mu. Here is 4 is remained. when you will write rho v hr divided by mu into equal to 2000, and this 4 will come in the denominator, so this will be cancelled out, so 500. So in case of, the conclusion is, the conclusion in case of pressurized flow, your Reynolds number is 2000 in case of laminar. In case of open channel flow, the value will be 500. How? Just here I have explained you. So this is the conclusion. So that is a 4 times less. So that's why in case of turbulent, open channel turbulent flow, your value will be for turbulent 1000 greater than equal to 1000 for turbulent flow. But in case of pressurized flow, that is pi flow, the greater than equal to 4000. So remember please, if any student have any doubt, so you can reply, or you can ask in the next class. I'll take in on Friday, or you can reply, or you can ask in the video comment also on YouTube. Okay, so this is the basic concept about your open channel flow. But here just I want to tell something more about the open channel flow. So the classification of open channel flow, here is classification. So as I have told you, the free surface flow, open channel flow is a free surface flow. Here is very in the fascinated way the definition is written. The open channel flow refer to the flow of liquid in channel open to the atmosphere or partially filled conduit. Partially filled conduit means if your channel is like that, circular, but it should be partially filled, then it is also known as your open channel flow. If it is completely filled, then pressurized flow. If it is completely filled, but if partially filled, means that the meaning of free surface, and is characterized by the presence of liquid gas interface is called the free surface. So remember please, most natural flow encountered in practice, such as flow of water in creeks, rivers. What is creeks? Actually you can Google what is creeks. Creeks is nothing but, you can say, the small kind of the channel, a small type of channel you can say, but you just Google and you will see very clear picture of the creek, river, and flood, as well as the draining of rainwater of highway, and the parking lots, roof, open channel flows are open channel flows. So the human made open channel flow system include irrigation system, sewer lines, drainage ditch, and gutters, and design of such system is an important application area of engineering. So remember please, the for application point of view, the open channel flow is very important for a civil engineer. Okay, for other engineers also, irrigation engineers also, agriculture engineer also. Okay, so here is a one diagram is just you can see this diagram. The velocity, the typical constant axial velocity contour in open channel flow of trapezoidal section, values are relatively average of velocity. So here is, as you will see, as you know already, at the wall, you know the velocity is 0 due to the no slip condition. So as you move far from wall to mid of the channel, your velocity will be increased, because the effect will be reduced. The effect of wall will be reduces from here to here. So as you will see here, at that your velocity is 0, little bit above, that is far here, and from here to here little bit away from the your wall, the velocity is 0.05, little bit more away 1, little bit more away 1, little bit more away 1. So similarly 1.5, 1 point in the middle, that is a core region, your velocity is very high compared to the wall. So remember these things. Flow may be one dimensional, two dimensional, or three dimensional. Flow may be steady or unsteady. Flow may be uniform, non-uniform. So what are these? I'll discuss. So here also. So here I have just talked a little bit about your non-uniform flow. Non-uniform flow. Non-uniform flow may be gradually vary or may be rapid vary. So maybe gradually or maybe rapid. Maybe rapidly varied flow. Gradually, that is your GVF, gradually varied flow. Here you can see the depth is varying very gradually. Here RVF, depth is varying very fast. RVF, the here is depth is this much, here depth is this much, here depth is this much. So RVM is rapid. Within a short span of length, the depth is varying much compared to the your previous, that is the gradually varied flow. So remember please always, laminar and turbulent flow also possible in case of open channel flow. So here as we have seen, so let me just take water a little bit. Okay, so the flow may be, let me just, flow classification, it may be steady, unsteady, uniform, non-uniform. The non-uniform may be gradually varied flow and rapid varied flow. Laminar, turbulent, the critical, subcritical, supercritical. In case of open channel flow, the compressible, incompressible, okay. Anything else? Yes, 1D, 2D and 3D also possible. So 1D, 2D and 3D means what? Let us assume this is the open channel flow. If water is flowing only if the channel is like that, if water is flowing in this direction only velocity 1, that is v1, only the in the length direction, so that is 1D. If water is flowing length as well as width, the length also and width also, water is flowing laterally also here. In the length direction water is flowing like that and lateral also, so this is v2, this is v2, so 2D, that is v1. If I write here, this is your length direction, this is your depth direction, length, depth, and this is your width. Width direction. So in case of your length and width, water is flowing 2D, and 3D in case of vertical also, water is flowing vertically, V3. Generally in river, you can visualize the 3D flow. You can, on the top surface of river, you can visualize such type of flow also you can see. That is the voids, vortex. So these are due to the three-dimensional flow in the river. Okay, what is compressible and incompressible? The compressible flow, the density changes, or incompressible flow, density not change as water is flow. Water means as fluid is flow. So this is the, but in case of compressible, density will be changed. Critical, subcritical and supercritical, as I have told you, it depend on the your fluid number. It depend on your fluid number. Right, FR. That is V by root G A by T. And what is laminar and turbulent? I have just discussed you here, also written very well. And again, uniform and non-uniform. The uniform flow means with respect to time, if I write here is depth is, let us suppose, is 1 meter. Here also depth is 1 meter. Here also depth is 1 meter at a particular time, not particular time. If I see the flow is at 10 a.m., the flow is 1 meter. At 11 a.m., flow is 1 meter. At all places, not here is 1 meter, here is 2 meter, not. At 11, at 12 p.m. also, at 1 p.m. also, the flow is always 1 meter. So that type of flow is known as uniform flow. And non-uniform flow, you know, the depth will be vary with respect to space, with respect to space. Remember please, with respect to space. Oh, here is, sorry. Here uniform flow means at 10 a.m. if your flow is 1 meter, 1 meter, 1 meter at that place, okay. At 11 a.m. here is flow is 2 meter, 2 meter, 2 meter. Also uniform flow. At 12 p.m. also your 3. If the flow is 3 meter, 3 meter, 3 meter, okay. The steady case, the previous case, that is what I was discussed about, the with respect to time should also constant. That case was a study. Let us suppose at a particular space, the particular place, at that cross section, at 10 a.m. your flow is 1 meter. At 11 a.m. also 1 meter. At maybe here change. Maybe here your flow may be change. Here maybe 1.5 meter. At 12 p.m. your depth here is 1 meter and here is 1.5 meter. Okay, at 1 p.m. here is 1 meter, here is 1. So this cross section is your, means here water is flowing steady, here also steady, but not uniform, because here is with respect to time your depth maintain 1 meter, here maintain 1.5 meter. So this is not, you can say this type of flow is not your steady uniform. But if the depth is also maintained over the period of time and with respect to space also, so that type of flow is known as steady uniform flow. Means your velocity or your depth of flow, your velocity with respect to time is constant. Velocity with respect to space is constant. This is definition of a steady. This is definition of uniform. If both is a flow following the both definition known as steady uniform flow. So generally at BTech level we discuss more problem on the steady uniform flow. Steady uniform flow, remember please. And this is the Reynolds number what I was talking. Laminar, transitional and turbulent, maybe your open channel flow laminar, transitional and turbulent, depending upon the value of Reynolds number. So here is Reynolds number is defined as your V rho V RH by nu, or here you all know the kinematic viscosity is nothing but your dynamic viscosity divided by rho. So this is replaced by, if you will write rho here, so this is written like that. Remember please. So what is hydraulic radius actually? RH is your hydraulic radius. I have already told you. RH is hydraulic radius here. You can see. Or you can say HR also, somewhere you can see, and somewhere RH also. So here is the cross-sectional area AC and the weighted perimeter P. So similarly, or what is hydraulic diameter? Hydraulic diameter is 4 AC by. So we can see here that the hydraulic radius is in fact of 1/4 rather than 1/2 of the hydraulic diameter. So 1/2, you know already, in case of your circular, we actually relate the diameter like that. Radius is 1/2 of your diameter. 2. But here is not like that. Your hydraulic radius is 1/4 of your hydraulic diameter. Remember. Okay, now we'll move on the next. Here is the Froude number. The LC is characteristics length. The LC is taken to be flow depth Y for wide rectangular channel. Remember please, for wide rectangular channel we'll take LC as Y, and FR is equal to like that, what I was discussed. If your Froude number is equal to 1, that is critical flow. If your Froude number is less than 1, this is subcritical flow, and FR is greater than 1 is supercritical flow. Remember please, very very important concept. Okay, so we'll move on the next. Here is very important concept, the specific energy. One thing here I want to tell you, a very very important thing, just out of context. As you all know, just for your kind information, the Y is a function of Fx. So this is your independent parameter. This is your independent parameter. And this is your dependent parameter. Right? As we will put here the value of, oh sorry, this is your independent, and this is your dependent value. And this is your independent parameter. Means, as we will put the value of 1 here, according to 1 and according to function, maybe Fx will be your x square plus x plus 3. As we will put the value of 1 here, you will get accordingly y. So y is depend on x. So that's why you are independent to put the value of x. Maybe 1 you can put, maybe 2 put, maybe 3 put. On your whatever you will put here, on that value your y is depending. So that this is your dependent value. Similarly, your velocity is a function of your depth. If your depth in y direction here, so you can write y. Velocity is a function of y, means this is independent and this is your dependent parameter. Let's just I'm telling you, just you draw the diagram. So you will write the axis. So here you will write the x-axis and here you will write the y-axis. Means, let us suppose at the place of y-axis I am writing P, and at the place of x-axis I am writing Q. So here you will write the Q and here you will write P. Right? Means at the y-axis you have put what? Dependent parameter, and at the x-axis you have put independent. So this is a general way. This is not mandatory, but this is a general way. On y-axis we put dependent parameter and x-axis we generally put independent. This is not mandatory, but we put these things. But here if you will see, in case of velocity, the independent parameter should be on x-axis. So your y, this value will be here. Maybe y you can say, if I write the z in case of depth, let's suppose your y is representing d. Okay, so independent parameter you will write here d, here not y, d, and your dependent parameter you will write here mu. But velocity diagram, when you will draw the velocity diagram, generally, that is the general convention in mathematics should be this. But in case of fluid mechanics, we change the velocity, we write on x-axis, and depth we write on y-axis. Why? Because of, in case of flow, we generally take on y-axis, that is a vertical axis, we generally take depth. So just for understanding, just for simplification, just for simple understanding, just for make the simple understanding, we take the depth on y-axis, that is the your independent parameter on y-axis and dependent parameter on x-axis. Here is the slight change just for our convenience, just for on our understanding. So generally we draw the your velocity like that. As your depth change, your velocity increases with respect to depth. But actually, as per the conventional, this independent and dependent, your if your velocity is here and depth is here, your velocity diagram will be like that. But it doesn't look the understanding, but it doesn't look the very clear. So that's why we put like that, so it will be very clear to understand. Here is a depth, because vertically depth, here also in channel or in pipe we represent the depth in vertical direction. So this is look actually self understood, but this is not self understood. So this is the concept behind your axis. Okay, so this was out of your context, but was important. Okay, so if anyone have any doubt, you can write in the comment box. You can write, means after uploading my video. Okay, so this was a very important thing. Sometimes people confuse about why the axis is different than the general axis convention. Okay. So here we are talking about the specific energy. The formula of a specific energy is, as you all know, the total mechanical energy of the liquid in the channel in terms of head, that is your Bernoulli's equation, is H is equal to Z, that is your datum head, plus pressure head plus velocity head. But in case of open channel flow, generally we take your datum the bed of the channel. The datum we generally choose the bed of the channel. So datum head here is 0. So 0 plus P by rho z plus V square by 2z means this H we convert as a energy, that is a specific energy, like that. Here is one thing very important. Previously this term we generally tell head, but here why we tell energy, specific energy? Why not we tell here the head, that is a specific head, or head we generally head, because this is the total head, this is also total head. Here is the datum is 0 because we have considered, but why a specific energy? This question I'll leave remain. You just go through book, or you can ask your professor in your college, or you can go through the Google also. Why we write this term a specific energy, not head? Because this the formula is coming from the this only. The your head, that is a total head. This is your total head. But the datum we have considered at the bed, so only we have just put the 0 at the place of z, and this term that is head is we have written the specific energy. Meaning is same. Specific energy is your total head here if you consider the datum as a bed. But why specific? Why a particular name specific energy? So this question is remain. Anyone can reply or anyone can discuss in the next class. Okay. So now we'll move here a little bit. You can say the sum of pressure and dynamic head of liquid in open channel flow is called a specific energy and is expressed as like that. And this is given by your this back def 1932. So here what is your Z is the elevation head, P by rho z, that is equal to Y is a gauge pressure head, that is the gauge pressure head, remember, and V square by 2g is the velocity or dynamic head, you can say. The total energy is expressed in equation 1317 is not a realistic representation of true energy. Here the little bit hint is given. Why specific energy? So the total energy is expressed in equation 1317 is not a realistic representation of true energy of flowing fluid, since the choice of reference datum and thus the value of elevation head z is rather arbitrary. So this is not true. The total energy not true energy. Why? Because of datum is depend on you where you will take. Okay, let us move. The intrinsic energy of fluid at a cross section is represented more realistic if the reference datum is taken to the bottom of the channel, so z is equal to 0 there. The total mechanical energy of fluid in term of head become the sum of pressure and dynamic head. The sum of pressure and dynamic head of liquid is in open channel is called the specific energy, and this is given by first the Backman 1932. So E is equal to, that is gauge pressure head plus dynamic head, or you can say the velocity head. Consider the flow in open channel in rectangular cross section and of the channel width D, and noting that the volume flow rate is, that is the volume flow rate here represented by Q. As you will note, the discharge is represented here by V dash, V dot. The average velocity is this. Average velocity I think written here. Yes. The average velocity is discharge by area. Okay. So here one diagram here is given. This is your total head. The length from here to here is total head. The depth, and the depth from here to here is only your specific energy, ES. Remember. And here you will get one curve, that is a variation of a specific energy with depth Y as a specified flow rate. So here you can see the specified flow rate means a specified Q. The value is this. For a particular Q in a channel, flow may be your, if the flow is here, maybe supercritical, maybe subcritical. The subcritical, your fluid number will be less than 1. In supercritical, your fluid number will be, this is that line, a critical line. The fluid number will be greater than 1 for supercritical. For a particular discharge, in a particular channel, flow may be supercritical, flow may be your subcritical. Right? Remember always. And at your critical depth, if water is flowing critical depth, the specific energy will be minimum. So these are the small concepts we'll discuss later. Okay, so here your specific energy formula will be like that, because V square, here is the V square by 2G, means V square means this square, and V dot, that is a V dot is nothing but Q. So Q square divided by 2G, and YB, that is B square and Y square, you can write very easily. So these are the derivations. So you can follow these things. And you have any doubt, you can discuss. So, okay. In case of rectangular, this number is very important. In case of rectangular, how it is? That is E is equal to Y plus V square by 2Z. At critical flow, Fr is equal to, velocity will be critical, and G, in case of rectangular channel I am talking about, GYC. The depth also will be critical, and fluid number will be 1. The fluid number is equal to 1. So Vc is equal to GYC into 1, means GYC. So we'll put here the value. That is, at critical flow, your energy will be, specific energy will be minimum or critical. YC, the flow depth also will be YC, and the velocity is GYC square divided by 2Z, means YC plus GYC divided by 2Z. GG will be cancelled out, and this is YC and this is 0.5 YC, so means 1.5 YC, means you can write in the term of fraction. So E minimum is equal to, for rectangular channel flow, that is 3 by 2 YC. So this is, remember please, sometimes directly question asked about it, what is the minimum value of specific energy in case of rectangular channel flow, if the discharge flowing is, particular discharge is flowing. So remember please, or a specific discharge flowing. So here is again numerical value. So the question 3 is, the flow characteristics of a channel do not change with time at any point. So just I have discussed about it. The flow characteristics of a channel do not change. Flow characteristics means what here? Because today I have time, so that's why I am discussing each term. Flow characteristics means maybe depth, maybe velocity, maybe density. Okay, so like that. Discharge, these are the flow characteristics. Reynolds number. So your flow characteristics, because Reynolds number is depend on this thing, so we'll not write right here. So flow characteristic, that is your flow velocity, or you can say the flow depth, or you can say the flow discharge. These things not change with respect to time, not change. That is constant, not zero, constant. What will happen at a particular point? At a particular point here, let us suppose with respect to time, t is equal to t1, again t2, again t3, the value is not changed. Means the flow is your steady flow. Remember please, the flow will be steady. In case of uniform flow, at a particular time t is equal to t1, the flow at a throughout the section will be same, throughout the length, throughout the space will be same at a particular time. But in case of a steady flow, at a particular location with respect to time. Remember. Question number 4. The specific energy, that is a specific energy of flowing water in rectangular channel of 5 meter width, 2 meter water depth, and discharge is given 10 meter cube per second. Question is here. Just people, you can try, you pause the video and you can write your answer. You just see your answer, or I can wait 1 minute. Just I'll take water in between. So question is asking about a specific energy. Okay, I'll take 5 minute break after this question. So specific energy, y plus v square by 2z. So y here is flow depth already given. What is v? V is discharge by area, because discharge is equal to area into velocity. So discharge is 10 and area is b, that is b is given 5 and depth is given 2, means 1 meter per second. So y is 2 plus 1 square divided by 2 into 10. I am taking just for calculation simplification. So 2 plus 1 divided by 20 means we will put here the point 0 5, means 2 plus 0 0.05, 2.05 will be the answer. But the unit here not written. This is a mistake. This is a mistake of the question. The specific energy in meter. Here also the specific energy in meter of the flowing water of rectangular channel with respect. Here unit should be in each option, unit should be there. If unit is not here, the question will be incomplete. because the specific energy having the unit of meter. Remember please how the depth is having the meter, unit having meter, m, that is meter. As per the dimensional analysis, as I have told you, you cannot add this, say apple and orange. You cannot add. You cannot add the apple and orange. You can add apple and apple. You can add orange and orange. So here you can add meter and meter, not meter and meter square per second. Nothing. Just let me just for your clarification, meter square, that is meter per second whole square divided by 2 into meter per second square. So here meter square per second square divided by meter second square. Second square will be cancel out and this meter will be only remain. So this is also having meter. This is y depth is meter. So a specific energy unit is meter, not 2 meter. That is 1 meter and 1 meter, not 2 meter. We are talking about here only the unit. Okay, so we can add magnitude. We cannot, never you add the, we can add only the magnitude value. We can add, but unit we cannot add. So here is the specific energy unit is meter. Remember please. So the next question is this. So please try. I'll take the 5 minute break here. So everyone please try. Okay, let us discuss. So the question is, let me just put it in full view mode. So the question is, if the depth of water in open channel is less than the critical depth, that is the depth of flow, that is the depth of flow you can say here, is less than the depth of flow, that is the critical flow. Means if I draw here the specific energy diagram, from this diagram you can very easily say this is your critical depth line. This is YC. So your depth is less. Upper is subcritical and here is super. So your depth is, if YC value, if it is let us suppose 2 meter, then YF will be 1 point maybe 5, 1.8, that is less. So it may be here, it may be here, it may be here, that is it may be 1 point, if this is 2 meter, it may be here 1.8, it may be 1.5, it may be 1.2, like that. So that is your supercritical. So here another name, that is torrential flow, tranquil flow, the critical flow, the turbulent flow. Turbulent flow is not possible. The critical flow is also not possible. The name here, the torrential and the tranquil flow. These two is very confusing term here. So which option will be correct? Whether the torrential or whether the tranquil? Very important question. And here type of jump also is very important. So I have already given you. So just please think, very important. Supercritical flow. Very important. So sometimes we know this type of flow, shooting flow also. Shooting flow. Let me just name here. The supercritical flow is shooting flow also we know. Also we know the torrential. That is the torrential name also, if you will, torrential. Torrential, shooting, supercritical is the same thing. That is option A will be correct for question number 5. Here the type of hydraulic jump, this is also important. Sometimes ask, the hydraulic jump are characterized into two main types. Angular jump, they characterized by smooth and gradually varying transition, and hydraulic flip or jump, which involve the sudden change and turbulent behavior depending upon the value of fluid number. The various type of hydraulic jump are tabulated below. First one is the angular jump, that is the characterized by smooth and gradually varying transition, that is the undulating type. If the fluid number is 1 to 1.7, that is the type of jump is angular. 1.7 to 2.5 weak jump. 2.5 to 4.5 is fluid number is varying, the oscillating jump. a small roll formation here will be, you will see. And in case of oscillating, water oscillate in random manner. 4.5 to 9, your the jump, we know actually the steady jump, roll, the water surface will be roll or jump action. And if your float number is greater than 9, that type of jump is known as strong jump. And water surface, you will look like, you will see at the place of a strong jump, very rough and choppy flow. So this is the, actually you can, in case of objective type question, so such type of questions may be asked, remember always. The next question, question number 7. The depth of water, the depth of water below the spillway and after hydraulic jump are 1 meter and 6 meter respectively. The head loss will be the head loss. So here is formula is written, the head loss formula. Okay, okay, formula is here written, but the question is on this. The head loss is cube divided by 4 y1 y2. Okay, so here you can put, so y2 value is 6 minus 1 divided by 4 into 6 into 1. So 125, 4 into 6, or you can write it direct, or 12.5 into 3 ones are 3. Okay, somewhere we are doing mistake. The formula is y2 minus y1 whole power cube divided by 4 y1 y2. So here value is okay. The depth of water below the spillway and after jump are 1 meter and 6 meter respectively. The head loss will be, somewhere we are doing mistake. No. Cube 125 is okay. And okay, here is we are doing mistake. That is 24. This will be 24, means 5 point something. That is A option will be correct. The second question, in open channel flow, the best efficiency of rectangular section, the ratio of bottom width to depth shall be. The for best efficiency of rectangular section, the best efficiency of the rectangular section, the ratio of bottom width, that is B, and depth will be. So you know R is equal to Y by 2. This is the best of your channel, rectangular channel ratio. Y means here, this is Y. So area by perimeter, Y by 2, and area is what? Y into B divided by 2Y plus B Y by 2. So here y and y will be cancelled out. Y will be cancelled out. So 2b is equal to 2y plus b. So 2b minus b is equal to 2y. So b is equal to 2y. So here is question is asking about bottom bit by depth. So b by y is equal to 2. So b by y is equal to 2. This will be your correct answer. So similarly, you will solve all questions. So I'll just show you one by one. If you have any doubt, you can ask me. Okay. So let me just discuss the question number 9 in rectangular channel. Then after I'll solve the previous year hydraulic engineering question, previous year hydraulic engineering or NPTEL questions. Okay, in rectangular channel, the depth of flow is 1.6 meter and the specific energy at a section is 2.7 meter. The flow condition is the specific energy is given you, that is y plus v square by 2z is already given. How much? 2.7. V square by 2z is given. Another, the depth of flow is 1.6 meter. Y is given 1.6 meter. For rectangular channel, so you know already E minimum is already you know 1.5 YC. So if let us suppose YC, if let us suppose this is YC, means what? 1.5 into 1.6. So this value will be, let me just 1.5 into 1.6, 2.4. It is coming 2.4, means whatever the minimum value is, your whatever the value is given, let us suppose if I draw this, if I draw this graph, the minimum value here is the critical flow. This minimum value is 2.4. If this was the YC, that is 1.6, but your actual value is given this 2.5. That is your, that is this flow is not critical. The flow is not critical, this YC. So it may be your subcritical, it may be the supercritical. So how you will identify whether your flow is subcritical or whether is flow your supercritical? The depth of flow is 1.6 meter already given. So another way is flow number V by Gy. Y you know already, G you not know, and but V you can calculate from here. 2.5 is equal to Y value is 1.6. plus V square by 2Z. So from here 1.5 minus, oh sorry, 2.5 minus 1.6, 0.9, 0.9 is equal to V square by 2Z. So here is 0.9 into 2 into 9.81. Okay, let me just take the root over the square root, that is V is equal to 4 into 2 meter per second. So now you can put here 4 into 2, 9.81 into 1.6. So 9.81 into 1.6, oh sorry, 9.81 into 1.6, it will give you 15.7. 4.2 and square root also I want to take you, because 3.96, 4.2 divided by 3.96. So it is coming FR is equal to 1 point, sorry, 1.06. Oh sorry, here 2.7 is given. 2.7 not 2.5. So recalculation, 2.7 minus 1.6, it is 1.1. This will be 1.1 into 2 into 9.81 and a square root 4.64, 4.64, and here is 4.64 divided by 3.96, so 1.17. 1.17, that is your FR value is greater than 1, means what? Flow is supercritical. So like that you will calculate. There are the many way for calculation, just your depend on your thinking, you can calculate. Here you can see, if your FR value is greater than 1, in case of 1.17, that is greater than 1, the flow will be supercritical or rapid flow or shooting, or the another name is torrential. Torrential flow. So remember these things. Okay. The next question. Next question is very very important. The Manning's coefficient and all. So you know already the Manning's formula. V is equal to 1 by n, y to the power 2 by 3 is to the power 1 by 2. If discharge is given, area into velocity. So B into y into 1 by n, y to the power 2 by 3 is to the power 1 by 2. So you just try to solve. Question number 12. A 1.2 meter wide rectangular channel bed slope and Manning coefficient is given this. The normal depth is calculation. So whatever you will calculate the yn value, that will be your answer. So here also you will apply the same formula and you will calculate. Here because discharge is given already. So this is all about your open channel flow, the basic part. Now we'll move on the your previous year assignment. Okay, I'll upload this all the PPT on Google Drive, you can follow. So now the assignment, week 6. Okay, very important questions. All questions have another concepts. So different concept. Calculate the fruit number. Let me just take blue one. So the calculate the fruit number of a channel. The discharge is given 450 meter cube per second. A cross sectional area is given 45 meter square, and the top width also given. The channel is cross sectional area is given, it may be, and the top width is given 5 meter. It may be any shape, but we know already the fruit number is what? The velocity divided by g, area by top width. So how we will calculate the velocity? Discharge by area. Discharge is 450 and area is 45. So 10. Velocity is 10 meter per second. So here you can put 10 divided by 10. I'll write just at the place of 9.81. I'm writing the 10 just for simplification. And area is 450 and top width is given 5. So here is 9. That is 90. So 10 divided by 9 into 100. So just you can take outside 3 and 10. 10 will be cancel out. So that is 0.33 will be. This is the fraud number. Somewhere we are doing mistake. Where we are doing mistake, where I am doing. Okay. 450. Okay, here area is not 450, sorry. Let me just take eraser. Area is not 450, sorry. The area is 45 and this value is 5. So only 9 here will come. That is 10 divided by 9.81 into 9. So let me just calculate accurately because I have calculated. So for your accurate answer, just 9.81 into 9. This much. Take a square root. 9.4. 10 divided by 9.4 it will come. Oh, sorry. 10 divided by 9.4. 1.06. So this value. A option will be correct. So like that you will solve the questions. So we'll move on the next question. Next question is, that is your supercritical flow. Okay. So these questions already we have solved. The fruit number is of the flow is equal to 1. So what type of flow is? Whether critical, subcritical, critical, supercritical or tranquil. Tranquil flow is known as the subcritical, remember. And the torrential. Torrential and the torrential we known as the supercritical and tranquil the subcritical. The critical, yes, fruit number is 1. That is V by G A by T is 1. Then you can say, okay, critical flow. B option will be correct. Next question. Okay. The critical depth for a rectangular channel. The critical depth for a rectangular channel is given by critical depth, that is YC. So here you can just think about what is YC and how we will calculate. So critical depth you know already, 1, that is VC divided by, for rectangular channel here talking about. So already you know, at the place of A by T we can write directly YC because critical, so that's why YC critical. So VC is equal to GYC. So take both sides square. So VC square divided by G. So this is the value. Matching, not matching. So in terms of small q, and what is small q? Small q is nothing but discharge per unit width. That is, discharge is equal to area into velocity. So area is equal to B into Y into V. So Q by B is equal to Y into V. So this is Q and this is V. So V is equal to small q by Y. So here we need to put, so VC is equal to a small q by Y square divided by G into YC. So here YC, here also you need to put YC. So this q square divided by YC square G YC. So here will be the YC cube, q square divided by G. So now you can write very easily. So YC is equal to q square by G power 1 by 3. So this is all about your critical depth in case of rectangular channel is. So here the answer is q square by G whole power 1 by 3. B option will be correct. And how we will calculate, just I have explained you. Next question, question 4. The question 4 is, in case of open channel, uniform flow is characterized by constant depth flow with respect to time. Already I have explained. Because after explanation, the solution of question will be very easy. Because we have already discussed a lot. And the hydraulically efficient channel cross section is one which carry maximum discharge under given condition of slope, roughness and flow area, which has the maximum hydraulic radius, which has the maximum weighted perimeter, which has the maximum hydraulic radius. Efficient channel means what? Efficient means that is the minimum expense and maximum discharge. The meaning is efficient means this. That is the engineered way. The minimum expense and the maximum outcomes. There is minimum input and the max to max whatever you need to gain, the maximum output. So efficient channel. So here is the maximum discharge under given slope, roughness and flow area. Okay. So that is perimeter will be ready. Perimeter will be less because if the perimeter will be more, the lining cost will be very, very high. So if your perimeter will be less, lining cost will be less, and your discharge should be maximum. So, okay, remember please. So option A will be correct here. Next question. Here is the hydraulic efficient channel cross section is one which carries the maximum discharge under given condition of slope, roughness and area. Now, six. Question number 6. A 15-meter wide rectangular channel convey 30-meter cube and water depth. Calculate the specific energy. Similar question here. Specific energy is 1.5, that is depth and discharge. Discharge and width is given, so already you can calculate the velocity, that is 30 divided by 1.5 into 15. So here, so hope you all got it, the concept. 30 divided by 30 divided by 1.5 divided by 1 point, that is 15. So 1.33 square divided by 2 into 9.81. So we will get 1.33 square into divided by 2 divided by 9.81 plus 1.5. So 1.59, that is your C option will be correct. So like that you will calculate everything. Next question. Next question is again here Manning's questions. A question related to Manning's. A wide rectangular channel is given with longitudinal slope is 0.0009 and the Manning's roughness has been SS 0.03. They calculate the normal depth yn channel. The convey the discharge intensity is 0. That is 1.5 meter cube per second meter. Means what? That is area into velocity, b into y into velocity. So q by b value is 1.5 is given. So q by b is equal to y into velocity. Y velocity you know already. Y y to the power 2 by 3 is to the power 1 by 2 means 1 by n and y to the power 2 by 3 plus 1 means 5 by 3. 5 by 3 is to the power 1 by 2. Here value is 1.5. So you need to calculate here the normal depth. So these all will be the normal. So 1.5 into Manning's roughness is given 0.03 divided by 0.0009 9 to the power 1 by 2 power 3 by 5 is equal to yn. So after calculation this, you will get what? Let me just calculate. Question number 7. 1.5 into, sorry, 1.5 into 0.03, 0.045 divided by, okay, this is 0.045 divided by 0.8009 power, that is square root 0.03, okay, 0.0303 will be cancelled out, so 1.5 power 1.5 power 3 by 5, 3 by 5, 0.6, 5 power 0.6, so that is 1.27. A option will be correct. So like that you will calculate. Okay, so the critical depth is the depth of flow at which the fluid number is 1, not less than. The fluid number is less than unity naught. The specific energy is maximum naught. The specific energy is minimum. Yes, this is correct. So just I have just shown you previously the diagram. Next question. Okay, how the 1.5 a rectangular channel carries uniform flow. The fluid number is 1.83. The ratio of critical depth to normal depth of the flow is, okay, the FR value is given 1.83. The ratio of critical depth to the normal depth. So the critical depth is, that is FR is equal to 1, that is VC divided by GYC. The fluid number is V divided by GYN normal. That is your normal depth here is this one, the depth corresponding to this fluid number. The critical depth is the depth corresponding to your this critical value, that is the fluid number 1. So from here the ratio of critical depth to the normal depth we need to calculate here. So here the problem is, if you will go through that, the problem is, let me just write, then you will face the problem. So if I write the normal value from here, just take the square both side, 1.83 square divided by V square by gy yn. So yn value is 1.83 square into g divided by v square, and from here your yc value is g divided by yc square. So here if you will take the ratio, then yc and v, that is vc and v, is again remain, so you cannot go through that, so you cannot apply this concept. So you need to think in another way how you will calculate the answer of this question in different way. Just try to think. So how I will proceed, let me just show you. You will proceed like that. That is your fruit number. The fruit number you know already is v by gy, or why I am writing the y in, because I am going to write the value of 1.83 here. 1.83. At the place of v, we can write q by yn, right? And gyn already here. So you know already that is the yc barabar q by g to the power 1 by 3. So q by g is equal to yc cube. So q by g is equal to what? Just take the square root both sides. So 1.83 square q square divided by yn square g yn. Q square by g is yc cube divided by yn cube. So yc but and yn is equal to 1.83 by 2. If this is cube this side, if you will remove the cube from this side, you see by, so you need to write 1.83 2, and this cube will be 1 by 3, so this 2 by 3. So after calculation yc by yn, you will proceed like that. So always remember, please, if you will not get the answer in the first way, you can proceed for another way. You have to prepare for that also. So a little bit tricky question. Okay, so next question is, for hydraulically efficient rectangular channel, the bed width is 8 meter, the depth of flow is, the bed width is 8 meter, the depth is, just I have told you, b by y should be 2, so means y will be 4. So remember, for hydraulically rectangular efficient channel, so already I have told you. Next question. Okay, the maximum discharge through a circular channel, the depth of flow should be equal to the maximum discharge through a circular channel. If you want to put the maximum discharge through a circular channel, the depth of flow should be equal to 0.95 times of the channel. if this is the depth. So for maximum discharge, you need to full up to the 95% of the depth. Next question. The next question is question number 12. In defining a fruit number applicable in defining a fruit number applicable to channel of any shape, the length parameter is the flow depth, hydraulic radius, ratio of area to top width, wetted perimeter. The length parameter in case of fruit number, the length parameter is the length parameter is uh, already I have told you V by root G A by T. So here we take the length parameter area by top width. Okay, one at the one place I think I have actually I have told you very, let me just see. Okay, here I think I was telling you in the first slide that is the your fruit number. Fruit number was the ratio of your square root of, I think previously I was tell you the something like the gravity force divided by viscous force. This definition was wrong. The fruit number was your inertia force divided by gravity force. The Reynolds number is inertia force divided by viscous force. So remember please, I think previously I was just tell you wrong, but now when I was gone through this last question, so just my mind is click on that. I think at here I was doing mistake previously, so that type of mistake should not be in future. You never do such type of mistake. Okay, sorry for that. So let me just check also the fruit number is the ratio of, okay, let me just verify. Okay, that time I was thinking, okay, yes, inertia force by gravity force. Remember, please, always. Okay, that time I was thinking maybe another number, maybe fruit number, and but the correct definition is square root of this. Always remember, please. Okay, let us move on the next question. That is the next previous year. This question was, I think, from your 2023, and this question 2024, and this question is from 2023, hydraulic engineering NPTEL. So here is the calculate the float number of a small channel. Okay, same question is, only the value is changed. Only value is changed, and the cross sectional area is 42. So top width is given this. So similar kind we will solve. Maybe this semester you will also get the similar question, but value will be changed. The next question, just let me just check. Yes, here the float number of the flow of the section is greater than 1, then obviously supercritical flow. Okay, another question. An open channel is one in which the solid boundary confining the flow are open at top. The solid boundary confine the flow are open at the top, and the liquid flow in closed conduit has a free surface. A closed conduit full of not. So B option. Okay. Next. In case of open channel, uniform flow is characterized by, that is the constant flow depth. Okay, next question. Similar type of question, I think, from previous to previous year also. The hydraulic efficient channel which carries the maximum discharge under. Okay, the similar question, you just see. Here also you need to calculate the specific energy. So already you know the formula, I think in your mind you know already. V square by 2Z. So just you can pause the video and you can write the answer and all. We just solve for your experience. Here also the similar question, a wide rectangular channel has a longitudinal slope 0.0004, and the previously was the 0.009, that is 0009, but here 0004, and Manning's roughness was previously question 0.03 and here is 0.02, and calculate the normal depth in the channel when the channel conveyor discharge 1.3, and in previous question was 1.5. So similarly you can solve for this also. Now the next question is question number 8. The uniform flow in open channel exists when the flow is steady, and this question is different from the previous question. The uniform flow in open channel exists when the flow is steady and the channel is frictionless, channel is non-prismatic, channel is prismatic, remember, channel is prismatic, and the flow and the depth of flow is constant along the channel. So best suitable option is D. Oh, sorry. So the D option will be correct for this. Remember please. Question number 9. As per the definition of uniform channel, you know already, the at a throughout the channel length, your depth should be constant. Your depth should be constant uh, with respect to the length of the channel, or with respect to a space, you can say. The rectangular channel carries a uniform flow of float number this, the ratio of critical depth to the normal depth. So this is where the previous question, in the previous question we have already seen, this was the very tricky question. So let me just explain for this question again. So if R you know already this, for rectangular channel here I think written, yes, rectangular channel. So V by root GYN, and V is equal to discharge by area, and discharge is equal to B into Y. So means Q by Y. So q is equal to velocity into y. Okay, so here velocity is so you can write here velocity is equal to q by y. So q by yn gyn. So we will take a square root q square by g yn cube. So this you know already, q square by g, this formula you know already, critical depth. So at the place of q square by g you can write yc cube. So q square by g I can write yc cube divided by yn cube is equal to fr. So here yc cube divided by yn cube is equal to fr. So fr value, fr square 1.2.83 square divided by, so yc divided by yn is equal to 2.83 to the power 2 by 3. So from here you can calculate very easy. So these are the basic concept. Okay, next question is your question number 10. For a hydraulic efficient rectangular channel, the bed width is 4, the depth of the flow is, definitely you know the B should be 2 times of Y for hydraulic efficient channel. So if the width is given 2, the depth will be 1. Oh, when if it is given 4, the your depth will be 2 meter. Next question, question number 11. Okay, question number 11 is, I think, similar question. For a rectangular channel 3 meter wide is laid on a slope 0.002. When the depth of the flow of channel is 1.5, what is the average boundary shear stress? Here is little bit different. Average boundary shear stress we are talking about. Average boundary. A rectangular channel is given. Width is 3 meter. Slope is given 0.002. Depth of the flow is 1.5 meter. So what is the average boundary shear stress? This question little bit different from your previous question. So the formula is gamma rs s naught. Gamma is nothing but rho z into rs, 9.81 into 1000, because I think water is given. Okay, here water is not written, so how I will take the gamma? Whether water is flowing and what is flowing we don't know. So how I will decide? Okay, the question I think have missed something. Here water should be written very clearly. A rectangular channel flowing with water having the width 3 meter, like that the question should be framed. Okay, so let us consider water is flowing. So here 9800 into R value you know already, A by perimeter. So area is given 3 into 1.5 and perimeter 3 plus 2 into 1.5. So like that, and S value 0.002, 0002, like that. So when you will calculate, you will get the answer is this, that is 9.81 into 1000 this, and your A by P value you will get this 0.7, and slope is given already. So gamma rs, remember please, for your shear stress, average shear stress. Next question. Okay, next question is similar question from your previous. So hope this session will help you lot for solving the question of week 6. So remember please all concepts. These are the very important concept for you. So always remember the fruit number, the concept of specific energy and the ratio of specific energy as well as your normal depth. And another concepts we have solved, yes, shear stress also, normal average shear stress and Manning's equation always remember please. And also you remember always this your graph, this one, specific, okay, this one, specific energy. This graph is very important. Always remember. So hope you all will get. If anyone have any doubt, please contact. In the next class, we'll discuss your doubt as well as you can comment on YouTube also. I'll go through. So thank you again and thank you all. Hope you will enjoy this session. Okay, let me just close.